Assalamu alaikum. I would like to welcome you all to ATC 2023 Student Paper Contest, Petroleum Engineering section. Before we begin with our papers today, we shall have an enlightening career counseling session by Managing Director, CEO, Schlumberger, Zoraise Tariq.
Can everybody hear me properly? Okay. So we have started a bit late, but so I will try to make sure that my talk to you stays within the 30 minutes that we agreed on. So if you are trying to, learn from me which career you should choose and what should you be after 10 years, you will not get that answer here, right? Because at the end of the day, in my opinion, you choose the career 50% and the career chooses you 50% as well. It's not the straight line that you decide. But what I will do is, I'm doing a bit of a self-publicity here as well, which I'm, I think, entitled to right now. I'll tell you what you are seeing in the background here. But I just came back from a hike. I went to the Everest Base Camp about a week ago. And this actually happened to me. So I was lying down on the way back one day and I realized that I want to see what this hike has taught me as a person, as somebody who's running a company, for example, or as a student who is trying to look for the next career. And it is surprising that I found the life lessons from these 11 days. And I think they actually will hopefully inspire you to choose the right career, okay? Because today, you are no longer in the environment where you can decide when you graduate from the university which company you will be 20 years from now and which position you will have 20 years from now, okay? What we are living in the age, not of the degrees, but of the skills. So what will be more important for you 10 or 20 years from now is what do you have in your backpack? And of course, I had a backpack when I went to this hike as well, okay? So let's see if this works. It does. All right, so who am I? So I told you I love the mountains, which is fine. Good to be in Islamabad, not too far to go for the hikes as well. My name is Zoraise Tariq. So I'll talk to you about these 5 subjects, hopefully in 20 minutes, so I can allow a few questions, not a lot of questions, because we have our chairs waiting for the technical sessions as well, okay? So my name is Zoraise. Nobody calls me that. They all call me Zoro. So you are friends now, so you can all call me Zoro as well. This name was given to me by my company, and you will be surprised to know I don't look that old. But on 16th of November, I will be 25 years in SLB. Okay, so my first company since I joined, and the big question that comes to everybody's mind today, especially in the younger generation, is how can you stay with one company for 25 years, right? And I have been searching for this answer because I'm not the only one, and SLB is not the only company. There are a number of companies out there where people spend long times, right? 25 years, 30 years. So what's the reason that that career stays in one company? For me, the answer was, it was never stagnant. Every 3 years, it was a different country, a different position, a different silo I was working in. So essentially, every 3 years, you get the feeling you're in a new job, while it's the same company. Because your manager changes, your peers change, your culture changes, your customer changes, right? The society that you're living in changes, so you feel new every 3 years. And that is, I think, what has kept me personally going, right? Family, so on the left is my family at home, and on the right is my family at work, okay? And I think I've spent equal times with both, right? So basically, I'm married for 20 years, so almost same time with both families. I've got 2 daughters and 1 wife, in this order. And I have got a very nice, beautiful family in SLB as well, which I'm very proud of because they have hosted me for the last 25 years, okay? My current assignment, I'm the managing director for Pakistan and Yemen, okay? And I've been in this position for almost 4 years now, okay? All right, so next go to the next one. If it goes from there. All right, so I told you that I will tell you the life lessons from the base of Everest, and hopefully they will inspire you to realize that what career means to you, okay, and how you can progress in whatever you're doing. Because like I mentioned before, what you are doing today will not be the job that you will be in 20 years from now, right? You will get better opportunities. You may specialize in a totally different environment, right? You may specialize, you're a petroleum engineer. 10 years from now, you might actually be a CTO, a Chief Technology Officer for a company specializing in IT, artificial intelligence, and machine learning. It can happen. You can be a geologist today, involved in large-scale operations. Tomorrow, you could be a project manager for a large refinery. Okay, or you could be a supply chain manager because you have handled large inventories of products or produce from the refinery as well. So the careers vary. Okay, next one, please. Okay, so now this is the 5 lessons that I learned myself, and I think they are applicable to when you start your career. The first picture you see is basically the stuff I was putting together for the journey. Okay, so when you look at this picture, you have my standard t-shirts, and then you have the snow gloves and the hiking shoes, which I will need when I reach, let's say, 5,000 meters, right? This all has to be planned at the beginning. If you start your journey and down the line you realize that you have missed what you needed at that part of your journey, you cannot continue the journey. So what is important is for you to realize early on in your career, which is 3 to 5 years, which direction you need to be 20 years from now. So when you are 3 to 5 years in the career, in my opinion, you decide, okay, 20 years from now, I need to be in management, I need to be in finance, supply chain, HR, I need to be technical or I need to be non-technical. And based on that, you start filling your backpack. And when you say you fill your backpack, these are the skills that you start adding in your backpack, which you will need for the times to come. Because when the opportunity comes 5 years from now and you don't have the right skills in your backpack, you will not be able to achieve what you want to achieve. Okay? You will realize, and I mentioned this to my daughters as well, your GPA from your university is the entry point. After that, it's your first job. 5 years from that point onwards is your last 5 years experience. 15 years later is your last 2 positions. Okay? That is how the headhunters will target you. So you need to realize where you want to be 15, 20 years from now. Some people are technical. I topped my university in engineering. I never wanted to be an engineer. I always wanted to be a manager. I realized that early on that I'm not technically savvy enough to go into research, for example, or technical direction, right? So I chose a different field. Some people are very strong technically and they might pursue. But then you have to realize, for example, that a technical career may need a PhD. Okay? So that has to be in your plan. Because if you don't have it 10 years from now in your backpack, you will not be considered for that role. Okay? The second thing, bite what you can chew. So what you see in this picture, this on the top is not very clear, is the peak of Everest. So this is from day 2 of the track, right? So you know where you are going. It looks very far, right? But how you achieve it is by taking the steps at your pace. Because if you overexert yourself, you will be out of breath. You'll be too tired and you will have to stop. Because I like to walk. Can you hear me? Yes. So you will be too tired to walk. Okay? So this is true for the career as well. Sometimes what we do see when we start hiring people is that they want to go too fast without having the sufficient experience in the current role. So if you start moving in that direction, sooner or later, you realize that you don't have the skills to manage the elevated position that you are in. So go at your own pace. Some people will be able to go faster. Some people will be able to go slower. Not everybody is the same. Some people like to move every 2 years. Some people don't like to move every 2 years. Some people want to stay 4 or 5 years in a job. It also depends on the type of role that you have, right? So please make sure that you understand your nature. Don't compete with everybody else. On the hike, I met a number of hikers. You know, I'm a bit of an average speed. Some people are slow, some are fast. Who cares if I reach at 1 p.m. and the other guy reaches at 3 p.m. or 3:30? Who cares? This is not a race. You're competing with yourself. And so is the career. This is something which I would like to advise people, that sometimes we look around ourselves and we start thinking, my class fellow has reached there, and this person has reached there, right? And then we start taking some actions in our careers which may not be correct. You just want to go to the next position without realizing whether that expertise that you're going for is actually something you want to do or not. If I'm not happy on this trail, I cannot do it. If you're not happy in your career, you will not progress. This is a fact. You can stay unhappy for 6 months, but you cannot stay unhappy for 20 years. Okay? Marriage is an exception. Okay? All right, so now, then climatizing yourself. And this is true again. What does it mean, climatizing? So I'm at 3,000 meters, I want to go to 4,000, come back to 3,000. Short trips, 3 hours hike. Similar for your career. Now let's say you are in a technical role, and now you want to move to supply chain. Okay? You want to test it out. You need to challenge yourself. Don't be scared of taking the challenge. That does not mean that you burn your boats. It does not mean that you're not ready to come back. You're testing yourself in a new role. You realize it's good or bad for you, then you come back. And if that was good for you, you take the next big step. Okay? But this is how you add the skills. You add the skill by climbing up to an unknown territory where you have not gone before, with the will that if I'm not feeling good, I have the will to come back. Otherwise, I'll get very sick. So same is happening with the career. You go up, you try something totally new, with the will that, okay, I'll give it my best shot, but if it doesn't work for me, I will not stay there for long. I need to come back to where I feel stronger. Okay, because that's where you will progress. Okay? Then stamina or speed. This is the yak, which is basically the animal that they use in the higher mountains to carry the heavy loads. So the question is, what is your strength? It is stamina or speed for a company, for an individual as well. Do you like to run fast, or do you like to take your time but carry heavy load? So for example, in a career, what's a bigger role? A bigger role could be managing director of a country. Agreed. But a bigger role also could be marketing manager of 10 countries. You can grow vertically, you can grow horizontally. Right? So which one are you? You want to grow this way, or you want to broaden your scope this way? Okay? Because the challenges that you will feel this way will be the same as you feel in the horizontal expansion as well. Okay? So don't be shy to think that I can only grow vertically. You can also grow horizontally. You can add more skills to yourself by saying, I want to be the marketing and technology manager. Okay? I want to be the exploration and development manager for smaller companies, for example. Okay? I want to be projects and exploration. Okay? That is how you gain the skill set. You're not growing vertically, but you're gaining your capability to be hired more. Okay? And finally, of course, this is a beautiful shot. I took it. This is the last light kissing Everest peak at the sunset. When you've reached your point where you want to be, what is next for you? Because realize that the sense of achievement is short-lived. This dopamine that we all humans have, where you get an achievement and you feel the same thing for projects, when you're doing projects, when you're achieving a tender, when you're bidding, when you're winning a concession, when the well delivers on time, when you do a well 50 days ahead of time, the feeling is very elevated. But then you will also feel that once you've done the celebration, you feel drained because the dopamine is gone. So now you have to set for your team as a manager and for yourself as an individual, what's next. Okay? Life today, for you especially, I'm talking to the younger people, my mentors here in the front, I learn from them. For the younger people, you have to learn and unlearn continuously. And this is the environment you will grow for the next 20-25 years. You will have to learn the skills. Today you will learn artificial intelligence and machine learning as a side subject. 5 years from now, most probably the petroleum engineering curriculums will include AI and ML algorithms to be part of that assessment, right? 10 years from now, you will need to be a guru in using the system software which can run AI and ML. Okay, so the things are changing and evolving very fast. You cannot stay at one point. You will have to learn and unlearn. Don't be shy of that. Okay? Next slide, please. Okay, so now, we are in Pakistan, so Chili's is a good reference. But basically, the question is, okay, so how do you progress? You need to build your brand. Okay, in our families as well, we always have that one person, we say, if there's a problem, he or she can solve it, you know. That's the brand. So how are you known, let's say 5 years in the career? Do people say that this person is a problem solver? He or she is a team player. He has a positive attitude, okay? This person likes challenges, right? So build your brand. How do you build your brand? Relationships. Number one, cannot emphasize enough. Okay, this is networking. This does not mean that you bother people with WhatsApp and LinkedIn messages only. Okay, this is basically about finding mentors for yourself and making sure those mentors are available to you. This is about finding people, ideally 3 to 5, who you can share your issues at the office with, who you can take their advice about as well, and developing industry relationships to learn from them, industry and personal as well. Okay, so relationships are important. You cannot work in an office environment if you can't work with people. Okay, so that's number one. Number two, embrace challenge. Okay, so which basically means if you want to be challenged, then you should challenge yourself. Okay. If you have to volunteer yourself for taking a role, a project, do that, because that makes you visible. Some of these suggestions I'm giving you right now are early part of your career. Of course, once you reach a stable 10, 15 year mark, you may want to, delay the changes that you're happening. But I always say that in the first few years of your career, keep all your options open. That's not the time to cut your options and say, okay, this door is closed and this door is closed and this door is closed, right? First few years, keep your options open because you don't know which door will lead you where. Today, we are all talking about new energy. Minister Saab talked about, going green as well. That will also require the expertise of petroleum engineers in terms of carbon capture, geothermal, geologists, hydrologists, right? You'll just be drilling for something different. But keep your options open and keep yourself abreast for these challenges. Find your spark. This is again something, some people are very good, very systematic, do work sequentially. Some people can do work in parallel. Some people can do multiple responsibilities. Some people like to be on one responsibility only. Which one are you? There is no good or bad. Everybody can get things done. But which one are you? Realize that and focus on it. Okay? So find your spark because then people will know it also. Consistency. So this part is very, very important, right? This part is very, very important. That when you get the job done, because these last two things are together, your management should be able to say, this person gets the job done. Okay, we give this person a challenge, a task, a project, this person gets it done. And that comes with consistency. So your results have to be consistent, okay, all the time, every time. It does not mean that you will succeed all the time, by the way. Huh? You will have some failures also. But what the companies are looking at, I mentioned this when we are hiring people, that companies like us, many other companies also, we are not hiring people, we are hiring personalities. Training, companies can impart. What they cannot change is your personality. Are you a team player? Do you have a positive attitude? How do you manage conflicts in the office? Okay, those things are soft skills that you need to learn because that helps you to get things done. Because all the mentors sitting in the front rows here will tell you, you cannot get things done alone. It is always a team effort. You go to any E&P organization, there is the GNG and there is the PE. There is the geologists and then there is the petroleum engineers and the geophysicists and the drillers. Right? Everybody has their own targets, their own markers, their own KPOs. So to get things done, you need to collaborate. And you cannot do that if your personality is not there for conflict resolution and collaboration. Next one, please. All right, and finally, well-being. So this one is very close to heart for myself as well, many companies also. What does it mean? It means that as you grow into your career, you will be challenged in some cases physically. You will be in the field, you will be sleeping less, you will be staying up and planning wells, but also mentally, right? You will have mental stress. And that stress can come from the targets at the office. It can come from conflicts at home, conflicts at office. You will have issues at home, and then you have to come to the office to work as well. So mental well-being is as important as physical well-being. And this is something which I want to you mentioned very strongly, because this can impact your career. Okay? If you don't know how to manage stress, time, change, you will feel depressed at times. You will feel agitated at times. If you don't know how to manage that anger, if you don't know how to manage that frustration, it will have a negative impact on your career. So mental well-being, which is all of this, is very, very important. I'm not saying all of you should start hiking, but do look after yourself physically and mentally, because mental well-being, I cannot underemphasize that. A lot of times when we see people break down in our offices, is not because of physical stress. It is because of anxiety, panic attacks, and mental well-being issues. Okay, because they are overworked, they are fatigued, they have family issues, and all these things mixed together to cause a mental breakdown. So please look after your mental well-being, whichever way. The prayer helps, the meditation helps, but please make sure that you do that. Last, please. So I'll just hope the video works so you can see the full panorama. If he can play the video, yeah. So the message here is, guys, okay, it will be tough, it will be upward, it will be challenging, but then you are rewarded. And when you're doing it, please enjoy the show, because this is your show, this is your career. So have joy while doing it. Thank you. Yeah, I've been asked if there's any questions I can answer. He's my boss, by the way.
No, thank you. It was very inspiring and really good speech, Zoro, as usual. So my question is for you for last 4 years, you're managing the operation here. Give me like 2 to 3 tips on how to manage conflict, how to, manage large operation where you have to deal with different customer. You have a lot of customer here. Meanwhile, also you have to coordinate and manage different department, different division. So I like you to share with us few tips.
No, I think good question. So I think for the conflicts, what I have realized in my career is that you don't need to fester it, right? So you need to resolve the conflicts early. Because what happens many times is we are shy to go and challenge the conflict, right? So basically we just want to live with it. And the more you live with the conflict, the bigger it becomes. And then it becomes difficult to manage, right? So the conflict in offices and otherwise, the best thing is challenge it up front. The best thing also is to not do it in the office environment. If you have a personal conflict, do it outside the office. Change the environment in which you're talking about. As far as the customers are concerned, not because Fahim Saab is sitting here, but customer is always right. And I believe in that, because at the end of the day, we are there to serve our customers. So what I've learned in my 25 years is to be straight and honest with the customer. We will not be always on the mark. We will not be always performing 100%. But we as a company, for example, always strive to give 100%. Sometimes we are there, sometimes we are not. But we need to be straight and honest with our customer where we have shortfalls, not be defensive, accept our mistakes and move forward with them and improve them, right? And this helps a lot, right? Because I think this is the constant learning that we need to do, because it's a two-way traffic, it's collaboration. Finally, yes, if you look at our organization as well, as many organizations, our structure is much flatter now. So we have had a lot of changes over the last 5 years since COVID, right? The organization has changed a lot. And that causes some conflict here or there, right? Basically. Now, I think it depends. Personally, I do believe that the organization copies the leader. whichever organization it is. And I can give many examples, whether it is, at home, whether it is the organization at the home, whether it is the organization in the office, political, non-political, it copies the leader, right? So remember, if you are seeing your organization do a certain task a certain way, it is most probably because you do that task that way as well. I've seen in organizations, people below the line try to imitate the way the CEO writes the email. Okay, so this is very, very important as you grow in your careers, that your organization will be your shadow. So whatever you're seeing in your organization, you need to do a reflection on yourself and see how you are doing as well. So this is something which I will pass you.
One more question. Yes. People who can't ask the question right now, Zurail is available here for the next 2 days. You will be also here. So get a chance to meet with him and ask the question, especially the students. So, Rizwan sir.
Thank you very much. This is Mohammad Rizwan Latif from UT Lahore. I'm a faculty member over there. And thank you very much for this informative and insightful presentation. So basically, the point which you are trying to make regarding the finding one's spark and finding the right recipe for one's career early on. So on the flip side, if we look at it, there can be a tendency among the fresh graduates of hopping and switching from one job to the other job. And that is going to mark a lack of consistency in their earlier career. So how would you comment on that side? Wouldn't it be detrimental to their long-term career, and wouldn't they be seen as a less loyal employee in the longer term for any new employer? Thank you very much.
No, sir, very valid question, and UET, once you said UET, the question is given, right? So for me, yes, I think very valid point. So like I mentioned, you have to keep your doors open, but that does not mean that you switch every 3 months, right? When you can't know your spark in the first project, you can't know your spark in the first 3 months. Majority of the companies, they take 2 to 3 years training people, right? So that your first job is your training ground, right? Whichever company it is, you need to learn from that company 1 to 2 years minimum, and then see which direction you want to move to, whether within the same company or outside as well. What is important here as well, I mean, many times I talk to students and they're eager to move on. And I tell them that somebody is actually training you at their cost. This is only going to happen in the first 2-3 years of your life on a job. After that, nobody's going to call you and say, let me pay you to train you, right? So use the first 3-4 years after graduation well. What I do understand at the same time, because of the job opportunities, the first job, normally people just take whatever is offered, okay, which is fine. Nobody's asking you to stay at home. You take the first job, whatever is offered. Believe me, the job is what you make of it, regardless of where you are, okay? You can make a job very big for yourself in a small company, and you can make a job very small for yourself in a big company. So it is you who will define what the job means. The branding aspect that I talked to you about, if you are a very strong petroleum engineer in a smaller company, the chances you will shine actually are more, because the organization is smaller. So the success is shared between less number of people, okay? So every job has its own plus and minuses, but I fully agree that you have to spend a few years to understand which direction what you want to go. All I'm saying is that sometimes you realize that this is the degree you have and this is the direction you have to go, but you may realize, sometime in the line that you want to switch to an equivalent field where your degree will help you, but you may want to go and test something else out which is not technical, right? Not everybody is going to stay in a technical role, right? So that's something you can do, but stability comes after a few years.
Thank you very much, Zurail sir, for a very useful talk for the students. We would love to have you extended, but we have to go for the. So before you leave, I would like to invite our SP chairman for Pakistan section, Mr. Fahim Haider, to the stage. Fahim sahab, please come and say some words.
Thank you, Zurail, for a very inspirational and detailed speech. I wish I had it once I started my career. So many lessons in the speech and the presentation, I think, which Suresh has covered very well. So thank you for that. And a couple of things which I would like to add with your permission. So one thing which is my reflection, rejoining this industry after 20 years here in Pakistan. Pay attention to details. If you want to be a good engineer, pay attention to details. Second message, accept if you have made a mistake. Don't argue. If there is something, once you do an engineering work, there is always things which do not go as per plan. The second message. And third is very important what Suresh showed about your branding. It's a very small industry. Your name travels faster than you travel in this industry. So make your brand. Look outside the entire value chain. It's not only petroleum engineering or GNG or reservoir engineering. You have to look at the entire value chain. And I think with the COVID, the downturn which we had, and now with the rising in oil prices and what Mr. Marzuki showed about the requirement of this sector for many decades to come, together with the initiatives of the green and artificial intelligence and machine learning, you have a great career ahead of you. So we are there to support you from SPE, we are there to support you from the oil and gas industry of Pakistan, and look forward to a very bright career for all of you who are here and who are not here. Thank you, Suresh. Thank you very much.
Sir, as a token of appreciation for Mr. Suresh,
I would like to thank Mr. Zurez for his very enlightening words for the young professionals and students present here today. I would also like to thank Mr. Fahim Haider for his words of wisdom. Now let's proceed on to the student papers. Before we start, I would like to introduce our chair for the session, Mr. Munib Ali Virg. Mr. Munib Ali is currently working as Manager Reservoir Development at Mari Petroleum Company Limited. He holds a master's degree in petroleum engineering from Imperial College London. He has been associated with the oil and gas industry for more than 18 years. Prior to working at MPCL, he worked with ADNOC, CGG Veritas, ENI, and Pakistan Petroleum Limited. Our co-chair for the session, Ms. Mehwish Khanam, is currently working as a production engineer at PPL. She holds a bachelor's degree in petroleum and gas engineering from UET Lahore. She has been associated with oil and gas industry for the past 8 years, having production engineering experience. Let's begin with our paper sessions today. Each paper will have 15 minutes. The first 10 minutes, after the first 10 minutes, we'll ring a bell so you know that the ending is near. And later on, 5 minutes you'll have for the question answer sessions. So our first paper is on impact of nanoparticles on wettability alteration for oil wet reservoir by Uzair Ali Rajpur.
Good afternoon, everyone. Let me start with the thanks to the management of ATC who gave me a great opportunity to highlight my ideas here. And let me start with this saying by a few words with my own background. I, Uzair Ali Rajpur from Mehran University of Engineering and Technology, Khairpur Miras. I had served as a Vice President of SP MUSET Student Chapter. And as you can see, our today's topic, impact of nanoparticles on wettability alteration for oil wet reservoir. So in our presentation, I shall focus on how to alter the wettability and what will the impact of nanoparticle in the wettability alteration in oil wet reservoirs. So these are the slide contents of my presentation. Is introduction, objectives, innovation, literature review, methodology, model data, results and discussion, conclusion and references. Introduction. As we can, as a petroleum engineer, we know that our oil and gas reserves are declined day by day. So researchers conduct the study for EOR to increase the oil recovery and decrease the residual oil saturation, and also minimize the injection fluid loss and increase the good sweep efficiency in the EOR. Innovation. Computational fluid dynamics CFD analysis makes it possible to examine the conditions that are impossible or difficult to achieve the laboratory conditions. In my presentation, I had a study on the simulation-based study, in which I analyze the effect of nanoparticles, which is impossible or difficult to analyze in the laboratory conditions. As a new hybrid EOR methods have been developed in order to apply these methods on a reservoir scale. It is important for companies to have a comprehensive knowledge of the different aspects of the process. Computational fluid dynamics helps to calculate all parameters each point of the target, but in experimental method, only a few points can be obtained. Objectives. There are my main two objectives of my research paper. Objective is to develop a suitable micromodel using ANSYS Villain and to simulate the oil displacement efficiency. In my presentation, I had simulated the two injection fluids in the micromodel. One is a water flooding and another one is the nanoparticle floodings. And to investigate and compare the effect of two different injection fluids, water and nanoparticles, on the residual oil saturation recovery. Literature review. Innovative micromodel pattern can be appropriately simply complex reservoir research properties that need to be presented. Here in the literature review, we can see here, these are the nanoparticles which are absorbed on the surface of the rock, which it is the main purpose of nanoparticles is to change the wettability of the oil wet reservoir. And it will achieve by the absorption of the nanoparticles on the rock surface by changing the oil wet reservoir into the water wet reservoir. Methodology. Base case selection. A micromodel design capable of reproducing oil recovery results similar to experimental results with lowest deviation of 5.17% was selected. In the base case study, before the pre-processing, I had selected the base case study, in which we ensured that a strong correlation between the simulation study and the experimental study. So that's why we select the good base case study. Geometry creation. In the second step, we had created the geometry of the micromodel, in which we design in the design modular, which consists of 123 circles randomly distributed with 60 by 60 mm rectangular. And third one is the meshing. Quadrilateral meshing was generated at high quality. The inlet is located at the right side and the outlet at the left side. In the meshing, we had select the inlet of the our micromodel where we inject the fluid, and whether one the outlet of the our micromodel. And in the 4 steps, we had a select the micromodel and in the model and put the data. Volume of the fluid, VF is the volume of the fluid was selected as the multi-phase flow. In the reservoir, we had dealing with the multi-phase flow, so we select the volume of the fluid in the simulation. Material properties of the fluid, the operating condition and initial condition, boundary condition was input into the setup. In the setup, we had put the initial and boundary conditions in our micromodel simulation, in which we in which we inlet of the first in the residual oil saturation in the micro model, and after it we inject the water flooding in one results, and in other simulations we had inject the nano fluid solution by post processing. Volume fraction contour plots for both water and nanoparticle flooding were extracted as the main qualitative results. Analysis and compare the results. When we done the simulation result, and then we calculate the water flooding and nanoparticle flooding, and then we find the impact of the nano flooding in the EOR. Model data. In the model data, we had select the 33% of the porosity and 60 mm by 30 mm of the thickness of the model. And I had picked the take the data from this research paper, which has the density and viscosity of the displaced fluid, also as well the displacing fluid. Results and discussions. In water flooding model, please play the video. First video. First. It is the water flooding, in which we clearly see it is red is our residual oil saturation, and this blue was our injection fluid. Okay, and when we inject the water flooding, these places are missing, in which we clearly see our water is bypass the oil saturation, and this phenomena occur due to the fingering. And in the nanoparticle micro model, in which we clearly see, in which no any body spaces are there, and clearly sweep the in which clearly sweep the oil by the displacing fluid. Results. Few large fingering fronts are formed. In the water flooding results, we can see the large fingering fronts are formed. Water blessed a small portion of oil in water flooding, higher residual saturation, lower oil displacement efficiency, and lower oil recovery. And in the micro model of nanoparticle flooding, we can clearly see the more branched fingering fronts are formed. Nanoparticle flooding displays the large portion of oil in micro model, lower residual oil saturation, higher sweep efficiency, higher oil recovery. Results and discussion. Wettability alteration. It is my presentation was the basic in which we clearly see wettability alteration. The main role of nanoparticle is to achieve to alter the wettability by the absorption of the nanoparticles, in which the wettability is measured by the contact angle, in which we in the before aging we see 135 contact angle, which is the oil wet reservoir, and wettable, and when we inject the fluid, it converts the wettability into the oil wet reservoir. 91 is after the aging, 91 contact angle was formed, and we measure the wettability is changed. The contact angle becomes an important issue where the surface tension is sufficient, focusing CFD results. In the CFD result, in the wall interaction, we put the data of angles which have first before the aging we have a oil wet reservoir, and after the aging it will convert into the water wet reservoir. This will show green line shows the water flooding, our reserve, and blue line shows the nano flooding. Comparison of CFD with experimental results. In the basis case study, I'll tells you, we ensured that the good strong correlation between the experimental and CFD results. I have done the CFD result, and I take the experimental results from this research paper, which is published by the Rostami in 2019, and compare the results, in which we in experimental results I had compared the experimental result with my CFD results, and it deviate variations from 5%. conclusion. 2D micro model design that 2D micro model design that represents 1:4 of the 5-star flooding pattern was replaced by using design modular. Water flooding and nanoparticle flooding was successfully simulated using VOF model multiphase ANSYS filter. Analysis shows that nanoparticles flooding improves traditional water flooding by reducing viscous fingering. In the results, we clearly see in the water flooding, the phenomena of fingering was occurred. Due to due to less viscous water bypass the oil saturation, and but in the nanoparticle flooding we clearly see when nanoparticles absorb on the surface of the rock, it will convert its wettability and higher the sweep efficiency in the micro model. And these are the references. And thank you.
Thank you very much, Uzair. The floor is open for questions.
Assalamu alaikum to everyone. My question is that in Pakistan, we are dealing with the cost effectiveness for any kind of technique we idealize. So can you please explain what kind of ER technique we will consider for the cost effectiveness while dealing with these problems like water fingering or water conning?
I had done work on the nanoparticle, flooding of the nanoparticle. We have dealing with when we have injecting the water flooding, we had mixed it in two different kinds of fluids. One is a polymer flooding. In polymer flooding, the viscosity of the water decreased by the polymer, and this I was present in the nanoparticle flooding. Also, it will decrease the phenomena of fingering by the absorption of nanoparticles, and it will, when the nanoparticles was absorbed on the rock surface, it will pushes back the oil into the from the surface of the rock, and the oil will get in the center of the porous in the pore media. Okay, when we inject the water or inject the fluid, and then the injecting fluid carry out it in towards the production well.
Is it really cost beneficial?
Yeah.
As compared to the techniques?
This is the most beneficial technique.
Because we are dealing with the cost effectiveness. The president of UEP has recently told me that in Pakistan, we are not using your techniques because they are not cost effectiveness. So my question was here to prioritize that which technique is really cost beneficial that can be used in most cases for Pakistan. Is it worth it?
Yeah, this is a cost effective.
Okay, thank you.
Slowly. How the nanoparticles are engineered to target the specific wettability in oil-wet reservoirs?
No, it sweep the. I had done simulation on the micro model of the reservoir, but when we apply it on the experimental results, we take the results, the how wettability alter.
Okay, thank you.
One last question, please.
Thank you, Uzair, for the presentation. Basically, what I understand from your presentation is that you have tried to reproduce the results through simulation that were achieved by Rostami et al. Through experimentation.
Yeah.
Is that so?
Yeah.
Okay, thank you. So, can you please share what was the reservoir pressure at which you applied this simulation?
No, in which no any reservoir pressure are applied, but in the initial and boundary condition, we had the in first we had the zero pressure in the outlet, and the inlet we had some 0.5 Pascal pressure, because it is the simulation of micro model, not any result in any reservoir model.
All right. So, do you think that it can be scaled up to the reservoir scale?
No, I had no.
Thank you.
The next paper that we have is a deep learning based approach in determining the shale gas in place using methane adsorption capacity in shale formations by Faik Azarabasi.
Thank you very much. It's a pleasure to be here. Before proceeding towards my presentation, I'd like to thank my co-authors, Engineer Shane Mohammad Ali Lalji, Engineer Syed Imran Ali, Imtiaz Hussain, Abdullah Zaman, and Mohammad Amaz. And lastly, I'd like to thank the Chairman, Department of Petroleum Engineering, Dr. Javed Hanif, for his kind support during this study. So a paper titled A Deep Learning Based Approach in Determining the Shale Gas in Place Using Methane Adsorption Capacity in Shale Formations presents a revolutionary approach, or I should say enhances our understanding of methane adsorption capacity in shale gas reservoirs. So our paper primarily focuses upon the development of a novel correlation for methane adsorption capacity by using a widely used deep learning language called multi-layered perceptron, which I will be referring to as MLP during the course of this presentation, to determine the shale gas in place using two sets of data: total organic carbon analysis, which is TOC, and adsorption isotherms. So we all know that shale gas has recently gained much popularity in the whole natural gas scenario. Hence, it's a very important parameter that we have to focus upon. So the problem, and in shale formations, basically natural gas exists in three forms. It exists as free gas, it exists as adsorbed gas, and as dissolved gas. Out of all these three, adsorbed gas accounts for the major component of the total gas in place. So therefore, the accurate prediction of adsorbed gas in place is very important for the prediction of it. Now, multiple studies have been done because shale formations are usually deeper compared to the other formations. So they range from 1,000 meters to 3,000 meters, and they have a high temperature range from about 30 megapascals to 30 megapascals pressure range and about 90 degrees Celsius temperature range. So numerous studies have been carried out at these pressures, but unfortunately these studies have not been able to measure the complexities in all these high pressure and temperature scenarios. Yep. So like I mentioned, the majority of the studies used adsorption isotherms. Now, when we talk about adsorption isotherms, we have three different types of adsorption isotherms. And these three types are the major fundamental types. The first are the monolayered adsorption models, such as the Langmuir model. And then we have the multi-layered adsorption models, such as the Toth model. And then we have the pore filling model, such as the DR model. Numerous researchers and numerous studies tried to, but the problem with these, try to develop on these models, but the fundamental problem associated with these models is that they rely more on the homogeneous side of the reservoirs, and they discount and they do not fully capture the complexities of shale in heterogeneous conditions, and as well as since they are isothermal models, so we cannot model them accordingly. Further work was done by Tang et al. They introduced a dual-side Langmuir model, but again, it improved the accuracy of the model, but the fact was that they oversimplified the heterogeneous nature of shale. Right. So other multi-site adsorption model was also done, but I think it introduced several parameters which increased the complexities of shale. So this was actually the problem statement of the entire scenario. And that's where we come in. What we do is that we introduce a data-driven approach. Like I mentioned, data-driven approach. As with any other machine learning model, you have to train the model, and data is very important. And then when first we get the data, then we train the machine learning model, and then we test it. So firstly, let's talk about from where we got the data. We got the data from published literature, which had around 310 shale samples, and they varied in lithology, and the samples were collected from North America and Canada, and with formations such as the Exshaw Formation and the Banff Formations. And the experimental procedure that was done was total organic carbon analysis and adsorption isotherms, right? That's it. So Yep, so this is the statistics of the input data. You can see the count, the mean, standard deviation, minimum, maximum, the variables. And this is the distribution of the data set. A major flaw in this set is that the data is not normalized. So we have to normalize the data set before proceeding towards the model. So the parameters that we selected were pressure, TOC, total organic carbon content, temperature, and moisture content. And we predicted the gas content in standard cubic feet per ton. So what we did is we simplified the model and we reduced the input parameters. Right? So like I mentioned, testing and training and testing the data set. So we used a trial and error approach and found that 85% of the data set worked. 85% of the data set was used for the training of the model, and 15% of the data set was used for the testing purposes. This is the pie chart which shows the distribution of the set. And this is the workflow. Like I mentioned, collecting the data set, establishing the minimum and maximum variables, normalizing the data set, which is very, very important. Then we split the data set, and then we test different topologies. I'll add on to this in the next slide. Then we calculate the error matrix, and then we fine-tune the algorithm, and finally we develop a correlation to determine the methane gas content. Okay. So let's talk about the multi-layered perceptron model, or the MLP model that we developed in this study. Firstly, we use Python programming language for the MLP model. And then, so basically with MLP model, what you have is that you have an input layer and then you have an output layer, and you have several hidden layers. So the hidden layers is kind of the black box thing. But what you can do is that you have to adopt a trial and error approach in determining the number of hidden layers and the number of neurons in each hidden layer. So we did a trial and error based approach and tested different topologies. So the optimized topology that we finally reached, and then we use the mean squared error as the benchmark to set that, okay, this topology is best for this. The final topology that we got was 5 hidden layers with 1000, 500, 250, 100, and 10 neurons respectively in each of these layers. We set the regularization parameter alpha lambda to be 0.001 and the ReLU activation function for the output layer. So this is the inputs. We have 4 parameters, the MLP network, and then we have the output. These are the parameters. Wait. So that's it with the model development part. Let's talk about the evaluation part. So we use common statistical measures such as the data coefficient of determination R square, root mean squared error RMSE, and mean absolute error MAE. Right? And so, like with any other machine learning model, we have 2 things. We evaluate its effectiveness in how well it predicts the target variable compared to the actual variable. So how much close are both values. Hence, we developed 2 cross plots, one for the testing set and one for the training set. And we found that our model performed equally well on both the testing set and training set and predicted the gas content accurately as compared to the actual content. So both of these are closer to the line of unity. So which validates that our model has very high accuracy. So the value of R square that we got for the testing set was 0.9899 or 98.99%, as you might say. And for the training set, it was 99.3%. And we also got very low RMSE values and MAE values, which was 2.443 and 1.697. The chart here shows the number of epochs that the algorithm worked and reached its final point. So we had to develop a correlation heat map. Basically what a correlation heat map does is that it determines the correlation between the target variable and all the different input parameters. So we had a correlation, and then we found that the moisture content, the gas content, is very closely related to the moisture content, followed by the temperature and the TOC content. These are the parameters that had the high positive impact, and then they had the high negative impact. So then we developed the correlation. This equation number 1 is the equation of the MLP model in normalized form, and this is in the denormalized form. So we break down the equation into different parts. Here we had the Gmax from our data set to be, Gmax is the target variable, 115.9 standard cubic feet per ton, and G minimum was 0. And then we found this was a ReLU activation function that we used. So it gives out a single output. Since we had a single output layer, it was a regression model. And then we developed this generalized equation for determination of the gas content. Right, so these are the variables. We had normalized pressure, normalized total organic carbon content, normalized reservoir temperature, normalized moisture content, weights assigned, and then we had the weights for the output layer. So let's conclude. Our proposed model was very accurate in determining the shale gas content, the methane gas content in shale reservoirs with very low input parameters. The data set that we used was easier obtained. The reason why we used a data-driven approach was that previous isotherm models were not able to fully, had some limitations. Either they were not fully accounting for the heterogeneity in shale, and they were more towards the side of homogeneous side of things. And so our data is readily available, and then we can propose that it could be used in real life scenarios. One limitation of our model was that we use data set from North America and Canada, but if we try to include more data sets from Pakistan, we could employ this method in local industry as well. That's it from my side. Thank you very much.
Okay, thank you, Faik. The floor is open for questions.
As you mentioned, like there were 310 samples. Am I right? So it doesn't seem that much big data set. Okay.
Right.
So we could use another algorithms, machine learning models such as a decision tree, okay, KNN, XGBoost. So why didn't you use those algorithms? And rather you chose training neural networks, which is a very difficult task. And how did you come to conclusion that neural networks will give you the highest efficiency accuracy? Since it's a regression problem, you could use linear regression or logistic regression. Those could have solved your problem as well.
Right. So like I mentioned previously, the heterogeneous nature of shale. MLP models are very good at determining the complexities of nature, right? So we had to basically, it's not a very simple issue that we can take 4 parameters and we can form an equation using simple regression like you mentioned. Neither can we use XGBoost, because XGBoost is usually used for smaller data sets. So that's, I think, that wasn't very viable approach. We did use XGBoost, but the result that we got wasn't very satisfactory previously. So like shale is very heterogeneous. We have heterogeneities in shale, and then we have to model like how each input parameter will affect the gas content. So we have to like the complexities of the model can be fully done by MLP. That's the reason that we used a multi-layered perceptron model. I hope that answers your question.
Slowly. What do you think about Simber formation regarding shale gas in Indus Basin? What do you think about Simber formation of the shale gas in Indus Basin?
So if Indus Basin has a simple formation, that we can probably use the regular isotherm models, because we're not saying that the regular isotherm models are completely out of date. What we're trying to say is that these models have some limitations, but obviously we can use these models, and then for more complex scenarios we can adopt our machine learning method as well.
Okay, thank you.
Thank you very much, first of all, for such a nice presentation. I'm Zuhaib from Mohol, Pakistan. Basically, my question is that as your project is about the gas content in the shale, so can you tell us about one or the 2 fields in Pakistan where we can apply these kinds of models for the shale evaluation, as it is basically a technology of the America and the Canada like countries, and we have a gas shale contents of trillions cubic feet. So please, can you evaluate one of the two fields where we can apply these kind of models?
So I think thank you very much, Zohaib. I think I pronounced your name right. Thank you very much for your question. So we could apply these formations in Rani-Goat formation as well. So we have shale complexities over there. It has dolomite, it has illite, chlorite, so the complexities of that. And as well as that, we could likewise in the Potwar plateaus area, so the northern area, we could utilize those formations.
And by using your model, what kind of basically predictive analysis results, or you can say that how much effectiveness we can achieve using your model?
So our model, like we said, was trained on data sets from US and Canada. So once we get the required data sets from Pakistan, I think we could effectively train our model, and then we can modify certain parameters and try to make it like a more generalized towards, or we could either we could go for two things. Either we could make it a generalized model for formations all over the world, or we could make a unified model for formations specifically in Pakistan.
Okay, thank you, Faik. I think we are running out of time now. Thank you very much for your presentation.
The next paper would be Unlocking Geothermal Energy from HPHT Abandoned Reservoirs, Carbon Capture and Utilization for Local Energy Transition by Abdul Samad CPO.
Bismillahirrahmanirrahim. Assalamu alaikum and a very good afternoon to all of you. Myself, Abdul Samad Sipio from Mehran University, Jamshoro. And I must say I'm really honored to be here. And as we go for the introduction, today the topic on which I'm going to present is unlocking geothermal energy from high temperature and high pressure abandoned reservoir, carbon capture utilization for local energy transition. Okay. As we go for the introduction, we first have to understand that increase in carbon dioxide emission and concentration causes increase in global warming, as we have been disruptively using fossil fuels, as it was our need. But now it must be our need to limitize and control the emissions and concentration of carbon dioxide. Thus, for the solution of this, we have a technology termed as carbon capture, utilization, and storage. The technique this research is based upon is geothermal energy. That actually means to extract the subsurface heat and to utilize it on the surface. And it is quite conventional method as compared to other, it is quite cost, I must say, environmental concern as compared to other conventional methods. We can also see here in the graph from National Oceanic and Atmospheric Administration, it reveals the data as the era of, in the 18th century, as the era of development and industrialization laid their foundation. It causes increase in carbon dioxide emissions, as well as it causes the concentration of carbon dioxide in the atmosphere that ultimately cause to increase the average atmospheric temperature. And second statement, problem statement, actually notify that using simple water in geothermal purpose faces some heat losses because it has less heating capability of absorbing heat. Thus, I'm using here carbonated water. Okay. So the research is based upon mainly three objectives. Firstly, to minimize the concentration of carbon dioxide from our native environment. Secondly, utilize subsurface heat from oil and gas reservoir to produce power supply or electricity at the surface for the local purpose. Thirdly, using carbonated water to minimize the heat losses. As I mentioned earlier, carbonated water has more ability to catch the heat from subsurface to the surface. Okay, This research is designed to be implemented on the area where high concentration of carbon dioxide are observed. Secondly, where the reservoirs having high temperature. Okay, the purpose of using carbonated water is basically two. Primarily, we have to dump the carbon dioxide into the subsurface because we have to minimize the concentration of carbon dioxide in the environment. Secondly, carbon dioxide is being used to prepare carbonated water because it has more absorbing capability as compared to water. Okay, this is the research methodology flow chart, and it emphasizes that how the research is conducted throughout. Excuse. Okay, this transition shows the different lithologies and formation as we have in the subsurfaces. And can you change the slide for me, please? Okay, this particular section shows high temperature reservoirs. Next, please. Okay, here is the plant of carbon capture or storage plant where carbonated water will, where we will be making carbonated water with the help of carbon dioxide, and it will be injected into the reservoir where this fluid, the carbonated water, will be having less temperature. And here, here is the production well where the heated fluid will be produced, and it will be at the surface, the heat will be exchanged that will help to produce electricity. Okay, so throughout the mechanism, we have analyzed some of the issues that must be noted. Firstly is the degree of corrosion. When we are injecting carbonated water through the tubing, it may cause corrosion. Thus, we have tested the test of corrosion. Okay, we have also conducted the test of fluid behavior in the reservoir properties. In this this section, the heated fluid, the room temperature fluid will be injected into the reservoir, where it will flow throughout from the injection well to the production well, and it gains energy or heat from the subsurface, and the heated fluid will be produced at the production well. Okay, in this particular section, we have also conducted the test that how much the conductivity of carbonated water has as compared to simple water. And throughout the process, throughout the mechanism, the thermal flow is also being analyzed and simulated. Okay, so this is corrosion tester, where we tested the corrosion, conducted the test of corrosion at 90 degrees Celsius. The time duration of test was 3 hours, and we used copper strip as it is most corrosive metal. Okay, this is the PVD cell that is situated in Mera University department. Thanks to the management of Mera University, the test of fluid properties in the reservoir, the fluid behavior in the reservoir properties was conducted in this cell under the guidance of my supervisor and with the help of lab expert. And this is the conductivity tester, and this test was actually outsourced from the Department of Chemical Engineer in Mera University. Okay, the thermal flow was simulated with the help of ANSYS software, CFD computational fluid dynamics. Okay, the result of corrosion test, you can also see here, it has been observed the corrosion effect has been developed up through level 3A, which is dark tannish. Henceforth, the level of corrosion is less than the damage to corrosion level. This observation revealed that carbonated water has less corrosion effect and can be used for geothermal energy generation. I repeat that we have used copper strip in the test, and this is the most corrosive metal. We are not using the copper into the tubing. The tubing is made up of an alloy. Okay, the first fluid behavior test in PVD cell was conducted is isothermal compressibility and density, where we can see at the degree of at the temperature of 80 degrees Celsius, the compressibility and the x-axis shows the increase in reservoir pressure. As we are being injecting the fluid, it caused to increase the pressure. As the pressure is being increased from the 0 to the 14,000, the isothermal compressibility is shown being linear. That actually plays a pivot role and an important role in this research that tells that the fluid, the carbonated water, will behave as a single fluid. The carbon dioxide will not be liberated, will not make two phase, it will behave as a single phase. And this test was also conducted at the temperature of 90 degrees Celsius. That doesn't show the exactly same trend, but it is quite similar. Okay, the second test was bubble point pressure test. This also plays as a cornerstone of this research. It shows that the bubble point pressure or saturation pressure was 68 psi. That means the gas will not be liberated. This actually shows that in 4.629 cc of water can be miscible with 435.49 cc of carbon dioxide, and that is quite enough amount of CO2 that will be compressed or miscible with the water. And this test was the conductivity test with the help of time duration. Okay, the result of an advanced computational fluid dynamics flow model depicting the injection of carbonated water into the high temperature, initially at 30, production and significantly higher temperature reaching 90 degree are showcased. Okay, this is an image of thermal flow that is being simulated. I have not enough time yet. Okay, this is a graph that shows as the fluid is being traveled from the injection well to the production well, it causes increase in temperature as it gains the temperature from the surroundings. Conclusion: the copper corrosion test tell us that we can use the carbonated water in the geothermal purpose, as well as CFD simulation also tells that the temperature is being increased throughout the time period, as well as the conductivity tells the same thing. The bubble point pressure plays a cornerstone point, as it tells the gas will not be liberated, not make two phase, it will behave as a single phase. Okay, lastly I want to mention that right now in the world, globally, every company, every industrial world are trying to inline their every project to achieve the sustainable development goals. So here are some goals that this research works cover. Okay, firstly, affordable and clean energy. Secondly, industrial innovation and sustainable cities and communities. And lastly, climate action. Thank you so much. It's time to welcome the question. These are the responses. Yes, please.
Thank you very much, Abdul. You went very fast in the end, although you had like 1.5 2 minutes available. Anyways, good work.
Thank
so
you.
Floor is open for questions, please.
Assalamu alaikum. My name is
Assalam.
Dr. Mohammed Haris from UT Lahore. This is a very interesting topic in the recent era of CCUS and geothermal energy combination. I have a couple of questions and I hope you can answer these two questions. First of all, if we compare the CO2 injection with water flooding, the surface handling of CO2 is not easy. That's the reason that's right now in the world, we cannot replace yet water with the CO2. That's why some pilot projects have been going on, but none of them have got success rate. So what's your point of view in this reference? Secondly, the main disadvantage of using the geothermal energy is that once the connection has been built between the injection and the production, your reservoir will not cover most of the area, because geothermal energy is that when the area is more exposed to the thermal conduction, then only then we can get. So if we use supercritical CO2, what I can say that it will move faster than water, and once the breakthrough has been achieved, then it will not produce heat from the geothermal, from the reservoir, as compared to the water. So what's your point of view in this regard?
Thank you so much, sir, for the question, and it's really a good point to be noted and clarified. Firstly, you mentioned that CO2 handling at the surface is very difficult. Yes, it is, but this research actually and this projects basically cover two main objectives. It not only produces heat for the local, but it also dump the CO2 into the reservoir, and this must be our priority from now onwards. Concerning to CO2 handling, yes, it is difficult, but sir, this is just an innovation and transfer to the green energy. There are some few carbon capture techniques that the whole world is working upon. Mostly the Middle East and Northern MENA region is working on these projects, and the projects, few projects plays a successful part in these projects. I must say Saudi Arabia, Norway, Canada are the countries where this project is being implemented. So sir, it's just an innovation from as a student. So if we are focusing on these challenges, yes, it can be researched, it can be studied. And sir, can you please repeat your second question?
My second question was basically once the connection has been built between the injection and production, then the supercritical CO2, because CO2 under the high temperature and pressure will act as a supercritical. So it will be just, you will get the break connection, and then it will not produce any heat, and it will just, you are injecting and you are producing from the other end. So how could you tackle, means definitely your purpose is to sequester the CO2 as well, but in the meanwhile you also need to produce the heat. So how would you overcome this basically limitation?
Okay, thank you so much for repeating. Sir, firstly I must say that yes, as well we are injecting CO2 and dumping the CO2. First, this is the primary purpose as well, but this method must be cost effective, so we must generate some amount to be operate the project. So sir, as we can see, we have been continuously producing the oil through the centuries. It is last two and a half century. We can analyze that the temperature of reservoir doesn't decrease so much. So it is a possibility that the carbonated water and these type of pilot project can minimally continues to 30 to 40 years at least. So as well as I must also mention that we are working on the depleted reservoir actually. So if there is the need of fracking, it could be possible to the reservoir to be fractured.
Okay.
Sir, hope I answered the
Thank you, Abdul. We can stop here. Just one last question, quick question and quick answer, please, because we have already overshoot the time.
Thank you for the presentation. You have explained in a very nice way, which is very clear to us. My question is that can you picturize the feasibility of CO2 injection in brine-containing reservoirs? Means there's saline water, and as you mentioned that it will conduct more CO2, and as a result, more heat will be produced, and more emissions of carbon will be there, which will contain distortus effect on our environment. So, is there any possible solution for it, or we just highlighting these issues?
Okay, brother, you want to ask that with using carbonated water, why don't we use brine water, isn't it?
Mentioning that in a brine-containing reservoir, there will be saline water.
Okay, I got it. If the reservoir is brine contained, so it's not a big deal because the temperature in the reservoirs, that is abundant reservoir, is 1400 psi. That will not allow the carbonated water to be liberated or to be react with any other elements, you can say. Hope I answer the question, sir. Thank you, brother.
Thank you very much, Abdul.
Thank you so much.
We're ready for the next presentation. Thank you.
The second last presentation for this session is Comparative Simulation Study of Enhanced Oil Recovery by Carbonated Water Injection versus Water Injection in Oil Reservoirs by Asjad Javed.
Assalamu alaikum. My name is Muhammad Abdullah, and thank you for having me. I am from UAT Lahore University of Engineering and Technology. And first of all, I want to thank SP Pakistan section for giving me this platform to present my work, and I also want to thank my teachers and classmates who helped me in doing this project. So I'll start with the scenario which is going on all around inside the globe. With the burning fuels across the globe, the carbon dioxide's footprint is increasing day by day inside the atmosphere. So this is creating a lot of problems like increasing temperatures, changes of the climates, and melting glaciers across the globe, which is causing some disastrous floods and impending and collateral damages to the ecosystem and environment. So basically the problem is, as a petroleum engineer or as an oil and gas sector, we are being blamed for creating all this mess. Because word says that you are emitting more carbon dioxide, or you are a major contributor towards these increased concentrations of carbon dioxide inside the atmosphere. They say that you extract the crude from the subsurface, which is being used inside the transport or inside the industry all over the world. Similarly, during the production and drilling activities, the carbon dioxide is being emitted specifically during flaring. An enormous amount of carbon dioxide is being added to the atmosphere. So as a petroleum engineer, as we are creating this problem, we accept this. But as an engineer, we should propose a solution for this problem. So at least we should inject that much quantity of carbon dioxide that we are producing. So there are a lot of carbon capture, utilization, and storage projects across the world. So we can take carbon dioxide from the air and can utilize, can trap back them into the reservoirs. Here is the plot of increasing carbon dioxide concentrations inside the atmosphere. If we'll keep on emitting carbon dioxides at a similar rapid pace, then we will reach about up to the 43.8 billion tons by 2050. So this is a very alarming situation for us. On the other hand, United Nations has proposed us with a mission of net zero carbon emissions and carbon neutrality by 2050. So my topic, I am basically giving a study apprehension on the carbonated water injection. So carbonated water injection could be the possible solution to this problem of increased carbon dioxide concentrations. So please. So there are two ways in which we can do carbonated water injection, as one of the presenters was explaining about the pressure, temperature, phase behaviors of carbonated water injection. But my topic is specifically to the comparison and analysis of carbonated water injection with the conventional or plain water flooding, so that I can show the superiority or the complex mechanisms that are being used by the carbonated water injection to enhance the oil recovery. So there could be two methods in which we can do this. One is by preparing an injection brine on the surface but as sir asked the question that handling single phase carbon dioxide on the surface is very difficult. So we made a new innovation in that case, that we will be injecting the carbon dioxide and water from these separate wells that are being drilled till the same depth. And instead of preparing an injection mixture at the surface, we'll be creating the mixture within the subsurface, because when carbon dioxide and water will meet at a miscible pressure within the subsurface, they will make a combined traveling front. So this is a better case as compared to instead of preparing an injection mixture at the surface. So it's not going further. So here are a few points which make it stand out if you compare it with the carbon dioxide injection and water injection. First one is the carbonic acid making inside the reservoir. When carbon dioxide interacts with the water inside the reservoir, there is a creation of an acid which we name the carbonic acid H2CO3. This acid basically interacts with the reservoir rock and change the rock mechanics, which is an additional benefit that in water flooding there is just a push, simple displacement, and there are a lot of problems created due to simple water flooding. The problems of water coning inside our production wells. So these are the additional benefits. So by the creation of that carbonic acid, there is a dissolution of the mineral that is been present, that has been stuck on the surface of the formation. And secondly, due to creation of carbonic acid, there is decrease in the pH of the fluids that are present inside the reservoir. So by the decreased pH, there is a protonation of acidic components of the oil. So intermolecular forces of the oil are decreased and oil gets swell and move to the production end with a greater efficiency. So to make our case strong, we basically considered a conventional oil reservoir having a permeability of 0.13, having a porosity of 0.13 and permeability of 100 millirc in X and Y directions and 5 millirc along the Z direction. So we made a conventional simulation file of an oil reservoir. So this is the methodology. We can similarly we consider a conventional numerical simulator, commercial reservoir simulator for making our file. First of all, we injected water at different rates and at different injection values, and then we injected carbonated water at different injection rates and different injection locations. So the graphs will show the integrity of the things which I am saying. So here is the data of the injection well locations and injection rates in case of carbonated water and water injection cases. So basically we are comparing both the techniques. We'll look a greater deal on the graphs. So look at the field oil efficiencies we are getting with the utilization of carbonated water and the field oil efficiencies we are getting by the injection of simple water. The field oil efficiencies or the oil amount which we can recover by implementing water injection is around 68% or 78%. Or by the carbonated water injection, we are getting a hike of almost an 82%. You can see in case 2 of our study, it's going almost up to 82%. So what's the reason behind this? Those acting mechanisms which I discussed earlier, that the formation of carbonic acid and playing with the rock and fluid mechanics, etc. So if we look at the field oil production rate graphs, so look at in case of water injection, there is a dip in the production at the very earliest stage of the time.
This is because due to the interfacial tension between the water and the oil which was present inside the reservoir, water started to bypass the oil that was present inside the reservoir, so it doesn't efficiently swept the oil. While carbonated water injection maintained not only the reservoir pressure but also maintained the production at a higher rate of 10,000 stock tank barrel for almost 1300 days of a production. It's such a long time. So the reason was the higher buoyant weight density of the carbonated water injection as compared to the simpler water injection. Similarly, we will see in the case of pressure maintenance provided by the carbonated water injection, it will tell us that it was a better case. So here are the cumulative oil production values with the different cases of water injection and carbonated water injection. The graph is showing the values, but it's a little blur here. It's almost, we are getting 10 to 11 million stock tank barrel if we are implementing water injection technique, and with the carbonated water injection, we are getting almost 2 to 3 million stock tank barrel more, as we are getting in case 2 almost 14.05 million stock tank barrel of the oil. So look at the pressure maintenance of both the techniques. Here in water, as I said, that due to the density of water, water will sweep down and will slump down to the bottom of the reservoir due to its density. So it will move towards the production well very earlier. While on the other hand, carbonated water injection, owing to its higher buoyant weight density, will move very slowly with a slow mobility and will sweep the oil present in the reservoir with the increased sweep efficiency. So the pressure maintenance is evident for that. So here are the final results of the field oil efficiencies and field oil productions we get in a comparison.
Last 5 minutes.
Yes, sir. So can you please again present that? The last slide of the results. Here is the proof of the things which I was saying, that water injection give us the results, mediocre results of the oil production, and in case of field oil efficiency, while carbonated water injection is uplifting the game with the increased oil efficiencies and increased oil production rates. So here are some references from which we taken the data of it. So this was all from my side and from this study. Any questions, please?
Thank you, Abdullah. Floor is open for questions.
Thank you very much, Abdullah, for such a great presentation. First of all, you have talked about the H2CO theory, carbonic acid, and it's very harmful for our reservoirs. It basically weakens the integrity of our reservoir. What do you say about that?
Before implementing this technique of carbonated water injection, first of all, on implementing on any reservoir, we will take the core samples of that reservoir. In the lab, we have some tests for the reservoir integrity, and those are the tests of the faults reactivation and cap rock integrity tests. Similarly, we also perform some pulse and interference tests to ensure the integrity, that while this formation will subsidize as a result of the dissolution of the minerals caused by the carbonated water injection or not. So before implementing, we take a note on these things, and also we consider these parameters. Similarly, if we discuss it with the side of wellbore integrity, that the combined mixture of carbon dioxide and water could cause the corrosion, we have a solution for that. As I told, that 2 wells are installed side by side in the 2 neighboring grids of our reservoir model, so that we are injecting carbon dioxide and water from the separate wells, so that they can mix together within the reservoir. They should not mix together inside the well bore, so that they could not cause the corrosion. So we are taking care of the things like well bore integrity and reservoir integrity as well.
Thank you very much.
Thank you, Abdullah. Nice presentation. Just a little question. Have you taken account for the wettability regarding your study case?
So basically, we were moreover considering the amount of oil that is being recovered. That term wettability alteration I discussed as an acting mechanism. We studied that a bit, but moreover the.
Okay, thank you.
Any more questions? We have time. If not, then I can ask one question. You have shown the graphs for mostly the recovery efficiency and recovery factor and cumulative recoveries. So what about the hydrocarbon pore volume injection? Have you tried comparing the results of simple water injection and carbonated water injection?
Yes, sir.
In terms of how much reservoir pore volume you need to inject to get the particular recoveries or to
Yes,
reach the particular recoveries?
we have considered to make a comparison and analysis. We considered this volume equality in case of carbonated water injection and water injection. For example, if I can show you, if I can get to that particular slide. So you can see that in carbonated water injection cases, first of all, for example, consider the case 1. The water injection rate is 5,000 stock tank barrel and carbon dioxide's injection rate is 10,000 SCF. So to equate both the volumes, because here is only water, so we converted the 10,000 SCF into equivalent barrels of the oil, which becomes almost 1781 barrel. It is equivalent to the 10,000 SCF of the gas in volume. So we added that amount 1781 STB to the amount of water we are injecting, so that both the cases can we make comparable with each other. So similarly, in case 2, there were 2 water injection wells. So the carbon dioxide injection is 10,000 SCF. Again, it is 1781 to be added to the water injection volume to equate the volumes on the both sides to make the case a comparisonal case. So we added 1781 by dividing 1781 by 2 and adding half of it to the injection volume of first injection well and adding half of it to the injection volume of second injection well. So both the volumes have become 3890 and 3890 stock tank barrel per day.
And I believe for the model you used compositional, right?
Yes, sir. I used Eclipse 300 for creating this model.
So in that case, did you also check the effect of, the permeability reduction with time as you inject CO2 because of certain aspects like asphaltene deposits, asphaltene onset temperature pressure and conditions reaching? Did you check that also, or just?
Sir, we had a site on the permeability. As I discussed that with the creation of carbonic acid, there will be the creation of preferential flow paths because it's an acid. After all, if asphaltenes are being deposited, then somehow the acid which is being created due to the phenomena that occurring by the mixture of carbon dioxide or water. So this acid, I believe, will remove the asphaltene deposits that are being deposited on the surface of the rocks because it's an acid at all.
Okay, thank you very much, Abdullah. Thanks for the nice presentation. We're ready for the next one.
The last paper for the session, experimental study on improving silica nanofluid stability in saline environment for enhancing oil recovery by Javeria Batul.
Assalamu alaikum, I am Javeria Batul and I'll be presenting the experimental study on improving silica fluid stability in saline environment for enhancing oil recovery. The co-authors of our presentation were Engineer Hassan Aziz, Mohammad Saad and Shahzeb. These are the contents we'll be following today. We'll start with the introduction and moving forward with the objectives, the methodology we used, the experimental work we performed, the results we obtained and the conclusions we made. As we all know that the resources are depleting, that's very important for the oil and gas industry, and our industry needs innovative techniques to be able to complete the demands, and any innovations calls for EOR. Among the different EOR flooding methods of miscible, thermal and chemical flooding EOR methods, chemical flooding EOR method is found to be the most promising one. As the study focuses on silica particles are usually unstable in ambient conditions. Therefore, it was very important to analyze the it was very important to investigate them and to prevent any clusters from forming. Similarly, salinity causes osmotic stress in the environment, which is a great environmental concern. Therefore, stabilizing silica particles in saline environment was very challenging, and we had to focus more on the dispersion, because as dispersion increases, as the dispersion the stability is altered because with increasing salt concentration. Therefore, it was important to investigate both the stability and the salinity in the environment. Our study had three main objectives. Firstly was to design a stabilized fluid in saline environment. Secondly was to use that stabilized fluid for enhanced oil recovery. And lastly was to simulate our study using CMG simulator. The flowchart here shows the methodology we used. We started off with the literature review. Firstly, we analyzed the particle. Then we prepared the fluid, performed tests on it. Firstly, the stability test, then interaction test, then used that result for CMG modeling. In the end, we were able to obtain results and finally concluded our study. Firstly, we had to determine the silica particle size. Therefore, we use, in figure 1, you can see it is particle size analysis instrument, master size of 3000, which was used for the analysis. This graph is the representation of the particle size at different percentiles. As you can see on the left hand side, at different percentiles, following results were obtained. Secondly was to determine the CMC. CMC is very important for colloidal chemistry. Therefore, we use concentration of xanthan polymer and measured the viscosity at 6 rpm using viscometer, and following graph was obtained, which gave us the result about 0.835837 weight percent. After that, we move forward for the preparation of a fluid. Firstly, we used deionized water as the base fluid and added silica particles with falling composition, and then performed sedimentation test on it, and we monitored the settling time. Amongst all of them, we weren't able to get some promising results, so we changed our base fluid from deionized water to xanthan gum. Firstly, prepared the xanthan gum using deionized water and xanthan polymer powder of 83 weight percent by adding silica particles with falling compositions, and then we performed sedimentation test on it, and following results were obtained. We were getting somewhat near what satisfactory result. Therefore, we move forward with preparing the fluid in saline environment. For that, we use NaCl salt. We prepared 3 different samples with base fluid xanthan gum, adding salt with different compositions and silica particles, and then performing the sedimentation test on it. Amongst the 3 of the samples, sample A was found to be the most stabilized fluid, which gave us the recovery of 3 days. After preparing the stabilized fluid, we move forward for a second objective, which was to use that stabilized fluid for the interaction test. For that, we used 2 different tests. Firstly was co-interaction test, and secondly was flooding test. For co-interaction test, firstly we prepared 3 different core samples, as you can see in figure 4, and table 5 shows the dimensions of that campus, and figure 5 shows the procedure we used for the interaction test. We then had to measure the porosity. For that we used saturation method. For that we immersed our core samples into water for 72 hours, then measured the weight, and by the difference of saturated and unsaturated weight and using the porosity formula, following results were obtained. Amongst the 3 core samples, sample C was found to be the most porous amongst them. We then used the stabilized fluid we had prepared earlier. In table 7 shows the composition of that stabilized fluid. Figure 7 shows the immersed core sample in silica fluid, and figure 8 shows the recovery we were able to determine using that silica fluid. After interaction test, we move forward for the flooding test. For flooding test, we created an artificial reservoir using a metallic box and stones with dimensions 12 by 12 by 5 inches. Figure 9 shows the procedure. We injected silica fluid in the model we created, and the recovery was able to be made. Firstly, we added 500 ml of water, which was then replaced with crude oil. The initial water saturation was 100 ml, whereas the initial oil in place was 400 ml. After injecting silica fluid, the stabilized silica fluid, we were able to get a recovery of 300 ml out of 400 ml. The graph shows the recovered oil. The green line shows the in place volume of oil, and the blue line shows the recovered volume of the oil. After performing the flooding test, we then move forward for our third objective, which was to simulate our study. For that, we use CMG Star software. These two, for the sake of comparison, we did 2 different modelings of water flooding model and an injection model. Using the CMG Star software, we were able to simulate our study, and we were able to obtain the following result. First of all, this is the oil rate result. Figure 12 shows the oil rate of the water flooding model, and figure 13 shows the injection model. As you can see that the water flooding model, the oil rate was constant for the initial 4 years at 1000 meter cube per day, but started to decline, and by the end of 1909, it came to 10 meter cube per day. Whereas in silica injection model, our oil was being produced for the initial 6 years at 1000 meter cube per day. It did decline, but did not as much as water flooding model, and by the end of 1909, as comparison to water flooding, the silica injection model was still able to produce 400 meter cube of oil by the end of 1909. These are the water cut results that were obtained. The water flooding model had an earlier water cut. By the end of 4 years, the water started to produce and started growing rapidly, and by the end of 1909, it went up till 0.9. Whereas in silica injection model, the water cut was much later, 2 years later as compared to the water flooding model, and by the end of 1909, it was still 0.5, not much as compared to silica model, as compared to water flooding model. Lastly, the BHP results that were obtained were as follows. The water flooding model, both of them, the BHP was 34,000 initially, but the water flooding model, the BHP started declining earlier and then started increasing again, which shows that there were some near wellbore conditions which fluctuated the pressure. Whereas in silica model, you can see that the water, that the BHP did started to decline, but with a constant one, and it kept on declining without increasing, which shows that our reservoir was producing in a stable condition. By the end of the study, we were able to obtain the following results. The particle size using master sizer, the mean size was found to be 8.97 micrometer. The CMC was found to be 8.37 weight%. Stabilized silica fluid was formed, which gave us the stability of 3 days. Co-interaction test was one which gave us a recovery of 75%, and the flooding test was also performed, which gave us a recovery of 300 milliliters out of 400 ml, the initial present. In conclusion, after monitoring the CMG results, we were able to compare both the results, and we found out that silica injection model gave us better recovery and better results as compared to water flooding model. In all the three results, the oil rate, the BHP and the water cut, in all the three of them, we get a better result in silica injection model as compared to water injection model. Therefore, after concluding all of the study, we were able to determine, and we were able to come to the conclusion that amongst the ER purposes, silica injection model was found to be the most promising and most helpful one. These are the references that we use in our literature review, and that's all from my side. Thank you.
Thank you, Javeria, for the nice presentation. We're open for questions now.
Thank you for your presentation. So my question is how we can identify that our core sample is water wet or oil wet?
We firstly performed test on it, wettability test on it. After that we were able to use limestone cores which were not oil wet. That's why we used it.
So is there any experimental test?
The wettability alteration tests are supposed to be done on the core samples before using the core samples.
Thank you so much.
Thank you very much, Javeria, for the presentation. Basically, from your presentation, I understand that you conducted the silica-based fluids stability test at the atmospheric pressure. Was that so?
Yes, sir.
Okay, so when you are going to inject it into subsurface, so there would be higher pressure. And how would the stability of that fluid play when the pressure is going to change or when it's going to increase in the subsurface? Won't it break, or would there be any change in the properties of that fluid because it has a lot to do with the production that we're going to get? Thank you.
Well, thank you so much. We take into consideration the salinity of reservoir. By the help of literature review, we were able to use silica injection fluid. By the literature review, many different literature reviews were available, which was a help for us.
Can you please comment on the stability? How would the fluid be stable? Will it be still stable at higher pressure, or is there going to be some change?
We did
just the trend.
The trend might change a little bit. We did perform the stability. We did heat up our fluid in the laboratory to check at if the stability does change. It did change, but not much. Thanks.
One last question, please.
Thank you for the presentations. And my question is, did you consider the Newtonian or non-Newtonian behavior of the silica fluid?
The non-Newtonian behavior. Thank you.
All right, thank you very much. Thank you, Javeria, for your work and presentation. Very nice.
Well, this was the last paper of our first session today. To present a token of gratitude to our chair and co-chair, I would like to invite Mr. Atar Sarati, Student Committee Chairman, to present their souvenirs, please. Sir Munib and Ms. Mevish, please come on the stage. Thank you so much, sir. The second session shall begin at 2:30 p.m. After the second session is over, we shall distribute the certificates to all the students that have participated. Please also communicate to your other fellow students to sharply arrive here at 2:30 p.m. You may all proceed for lunch.